Namaste, I am Akshay SP, working as Assistant Professor in the Department of Electronics and Communication at Vivekananda College of Engineering Technology. Today I am going to discuss about the experiment inverting and non-inverting amplifier using OpAmp. So basically OpAmp is an operational amplifier that is used to amplify the signal which are applied to two inputs of the terminals of the OpAmp. So OpAmp is a high gain DC coupled voltage amplifier with very high input impedance and low output impedance. So basically ideal OpAmp has some of the characteristics like infinite open loop gain, infinite input impedance, zero output impedance and infinite bandwidth and infinite common mode rejection ratio. So for OpAmp experiment we are using OpAmp741 IC. So this is IC diagram of pin 741 IC. So this IC has 8 pins. So you can see here pin number 2, there are 8 pins total. Pin number 2 is input inverting terminal, pin number 3 non-inverting, and output we are taking at pin number 6. Pin number 7 and pin number 4 are plus VCC and minus VCC respectively, and pin number 1 and pin number 5 they are offset null, and pin number 8 is usually not connected. So there are two types of amplifier we are going to discuss. One is inverting amplifier as well as non-inverting amplifier. First we will discuss about inverting amplifier. This is a circuit diagram of inverting amplifier. Here the input signal is applied to the pin number 2, that is inverting terminal, to input resistor R1, and non-inverting terminal is grounded to a resistor. And also there is a feedback resistor is connected from inverting terminal to the output. So in this particular inverting amplifier, so because of the very high open loop gain and negative feedback concept of the amplifier, the voltage at inverting terminal becomes approximately equal to the non-inverting terminal voltage. So in this inverting amplifier we will get the inverted version of the input signal. That is, if the input is high, we will get the output is low. If the input is low, we will get the output is high. So there is 180 degree out of phase between the input and output voltage. So this is a circuit diagram we bring up. So input signal is connected and it is given to the pin number 2. Similarly, pin number 6 we are taking the output which is connected to the CRO. The plus VCC and minus VCC supply voltage is given to the pin number 4 as well as pin number 7. For this input, so the output of inverting amplifier is shown in the CRO. So this is the input signal. Mainly we applied input voltage of 1 volt. For this input voltage, so the output is inverted version of the input, and it is, as I told, it is 180 degree out of phase with the input signal. So for inverting amplifier, there is a phase shift of 180 degree will be available at the output side. Now we will discuss about the non-inverting amplifier. So this is circuit diagram of non-inverting amplifier. Here the input is applied to the pin number 3, that is non-inverting terminal of the OpAmp, and inverting terminal of the OpAmp is grounded to a resistor. And also the feedback resistor is connected from input inverting terminal to the output terminal, that is pin number 6. So in case of this non-inverting amplifier, the input signal is applied directly to the non-inverting terminal of the OpAmp, and also the inverting terminal is grounded. So because of very high open loop gain and negative feedback, the voltage at inverting terminal becomes approximately equal to the non-inverting terminal. This causes the output to adjust itself so that amplifier produces an amplified version of the input signal. So in case of non-inverting amplifier, the output is same as input, but there is an amplified version of the input signal. So this is a circuit diagram of non-inverting amplifier. So again, input is applied to the pin number 3. So this is the signal that we are giving from frequency generator, signal generator, to the pin number 3, and from the pin number 6 we are observing the output. So this is a waveform of non-inverting amplifier. So this is the input signal and this is the output signal, and output signal is follows the input signal, but there is an amplified version of input signal. So coming to the gain calculations of this inverting and non-inverting amplifier. For inverting amplifier, the gain, the formula is RF, nothing but we have chosen 100k, and input resistance we chosen 10k. Gain equation for inverting amplifier is AV is equal to minus RF by R1. So for this we are getting a gain of 10 for inverting amplifier. And coming to the expression for gain of non-inverting amplifier, so that is AV is equal to 1 plus RF by R1. Again we have choose RF as 100k, R1 as 10k. So we are getting, according to this, we are getting gain of 11 in this non-inverting amplifier. Thank you.